Yes, welcome to the class, dear students. In today's lecture, I'm going to do the second lab on R programming. In the last class, we have done the how to construct the frequency distribution, the construction of the histogram, and then the how to plot the ogive curve. These are the things we have done in the last class. And now in today's lecture, I'm going to write down the code for mean, the standard deviation, the variance, and the coefficient of variance. These are the things I'm going to discuss with you today. Now, let us now start with the lecture. So to find out the mean and standard deviation, now what we do is, this is what the table of the class intervals, the frequencies is given, suppose. Then xm is what the mid values of the class interval, f into xm the product of the frequency and xm, and then square of xm values, xm square, then f into xm square you will find out here. And then you will find out the sigma of fxm and sigma fxm square, and this is sigma f. So this is what the table actually. So now how we have to construct this type of a data frame? We call table as data frame in R language. So now the codes for this is, let us look at the code properly. LCL means the lower class limit, UCL means the upper class limit. So we write the LCL as the sequence of all the lower limits and UCL as the sequence of all the upper limits, like C of all this. And then frequencies, you have to give all the frequencies. And then XM means what? The sum of the upper class limit plus lower class limit over 2. So 16 plus 20 by 2, which is 18. Like that we get XM values. F into XM values, 18 into 3 is giving you FXM. Similarly, xm square and fxm square, it is sigma fxm square. So these are what the data frame you have now. So we are going to construct to get such type of a data frame in our R language. So now LCL is C of this one I said, frequencies I said, XM is I said. Now let us come to the data frame operation. What is meant by this? I named the variable as df. Df is given by data dot frame of LCL, comma, UCL, comma, F, comma, XM, comma. So these are all what actually, these are all the columns which are there in the table. So this LCL is of course the class interval only. Frequencies we have written. XM is one column. F into XM is given by F star XM. Okay. XM square means XM hat 2. Fxm square is F star XM square. This is what the data frame we have to construct. And then when you say print df, then you will get the data frame. Let us now look at that now. Let us see this and then paste here so that we will understand what is this. So now the LCL, UCL we have got, frequencies we have got, up to here we will execute, and then data frame up to here we will print the data frame. Look at this now. We are able to find out a table with all LCL, UCL, frequencies, XM, F into XM, XM square and FXM square. So this is what the table construction using the command data dot frame. Then you will get this one. And then we need the sum of all the frequencies of this particular column. So when I say this particular column, the name of this table is what? DF, the data frame. In DF, we wanted a particular column, means you have to put dollar F. So DF dollar F, what is that? Sum of, that is N. Next, we will print N now. Let us see what is the sum of all these frequencies. That is what called as N. So this is 39 over. And then we have to find out what is the mean formula. Sigma fxm by sigma f. Sigma f we called it as N. So it is by N. So the value of mean is what now? Mean is given by sigma fxm by N. So now when you say print mean, then you will get the value of the mean. And then the numerator. What is the numerator? To find out the variance now. Okay. So to find out the variance, we are now finding out the numerator. What is the numerator? Actually, I just wanted to say here, to find out the variance, we are using now this concept of numerator. What is the formula for variance? Sigma fxm square minus sigma of fxm the whole square by n. So this is what the numerator. So please remember all this, particularly everything is Dollar $fxm square means it will take the corresponding column. Dollar $fxm means it will take the corresponding column again. So that gives you this value of the numerator. It will be printed here at 2035. And then when you say print in the numerator, then your console gives you the value. And then if you say what is the variance formula, whatever you have got the numerator over n minus 1, that is what the variance. So now what we see is a print of variance, and then standard deviation is the what square root of the standard variance, which will give you the value, and then print the standard deviation, you will get this also. So now we need the coefficient of variance given by the formula SD by mean star 100, mean into 100 now, so it is star 100. So now what is CV now? That gives you SD by mean into 100. So when you say print CV, you will get the value. So this is what the coefficient of variance. To find out the coefficient of variance, standard deviation, and to construct the data frame from which you are finding out the mean and variance also. So this is what the command, and this is what the program to execute for finding out the mean, median, and this one. Now I wanted to save this. In the last class, I have saved this as frequency distribution in histogram and OGM. Now I want to save this. So just to save as, and then you will be saving it as what actually? Finding out the mean, variance, standard deviation, and then you have the CV, coefficient of variance. So these are what you have in the commands. So now see here, when you save the when you save the document, it will be saved by default as .r file. It will be, even you can see this also. This curve, this particular graph we have defined, command we have given, and this is also when saved it is, you can observe it, right? So .r files. So by default it will be saved as .r files. So this is what, now you can see the environment column also, this also. So this gives you the values actually. I hope you could understand this. Thank you students. So in today's lecture, what we have done is to find out the mean, variance, standard deviation, the coefficient of variance. And in the last class, we have done how to construct the frequency distribution table. I hope you could enjoy the R programming. Thank you so much. Practice, then only you will understand easily. Thank you.